Okay, so for a pendulum, statics tells us this for small a, for small l. So we can write that as so. What follows from that? It follows that x is a two-parameter function, okay? Omega is not a parameter. It's the square root of k over m, okay? And I've given you all the details of where that comes from and how that's obtained. So I want you to go back and see where I did that, and kind of ask yourself how you missed it. Okay? I mean, I know how you missed it. You know, booming, buzzing confusion of dynamics and physics and everything else you're taking right now. But you missed it. Okay? Nobody's looking at me with a spark of recognition here. See, I'll tell you who I am again. No, that's not what I mean. Recognition of this stuff. Okay? Okay, also, potential energy is 1/2 kx squared relative to equilibrium. And I'll give you a hint. This follows from Newton's second law, which could be written as mx double prime equals negative kx. You can easily verify by plugging this into this that this is a solution. It's got two arbitrary parameters, a and phi. You know from calculus that when you find an antiderivative, you get a constant, right? Well, here you have a second derivative of x. Okay? Now you can't just integrate and then integrate because of the way this equation is. Okay, you got to find eigenvalues and stuff. You was asking me about that earlier. So in a sense, omega is related to an eigenvalue of this equation. Okay? And this is an eigenvector. But you'll understand that connection when we do differential equations. But that's, you got to do that sort of thing. So you can't solve this equation by a general method, but you can understand that this is a solution and that it has two parameters corresponding to the fact that this equation involves two derivatives. An equation involves one derivative, you just integrate it and you get an integration constant. If it involves two derivatives, you can't just integrate it twice. Again, you could if this is a function of t over here, but it isn't. Okay? So, that aside, from here, this is a median, if you understand a little bit of trigonometry at the 15-year-old level. Okay? What you get when you're 15 or 16 years old, or 13 or 14 if you're in the rest of the world that has educational system. Okay? Now, this follows very, very simply from the definition of potential energy. the definition of work, okay? So those are the principles. I want you to understand the details of how all this follows. And now we're going to talk just a little bit about how you apply it.
What is buy-in?